All right, guys. Moving on. We're going to talk about the next module. That's going to be Introduction to Node.js, and we previously talked about the MERN stack and those technologies, and we're going to talk about how we're going to introduce how Node.js fits into that, and basically what it is. So we're going to talk about these topics: the V8 engine, intro to Node.js, Node's core architecture, and basically installing Node.js. So we're going to talk about firstly the V8 engine and what that is. And when we're talking about the V8 engine, we're not talking about that engine on a nice car there. No, we're not talking about that. We're talking about a JavaScript server technology, and basically Node.js uses the V8 engine. I stand corrected. I'm sorry. The V8 engine is basically an engine that Chrome created, Google Chrome, open source high performance JavaScript and WebAssembly engine written in C++. It's used in Chrome and it's used in Node.js among other things. So basically, it's an engine that helps do that compilation down to that something that makes the browser and the server understand what all this scripting in JavaScript is, right? So the key point to take out of that is that it's actually written in C++. So even when we start talking about Node.js, we may think that we're doing JavaScript, but there's a lot going on under the covers, right? Like we talked about, like ES6, and some of those things are basically syntactic sugar over the vanilla JavaScript. There's a lot of things that happen as well in Node.js where you may feel like you are coding, you know, let's do some file operations, and I'm writing it in JavaScript, which it's ridiculous, really, if you came from 10 years ago to think that I am working on server side kind of operations using JavaScript, which you know originally it's just been client scripting in the browser. So like you would never even think, how could I say trigger a server restart with JavaScript. It would be just it'd be somebody would say you're crazy. But this new technology and all the stuff we're talking about, use of the V8 engine allows kind of some of the stuff, right? So it implements ECMAScript, which we're talking about ES6, which is the latest version of, well, it's not the latest version, but basically uh, iterations of some of those newer things in JavaScript language that has kind of been um, been has improved upon vanilla JavaScript that we had talked about in previous sessions, right? And it implements WebAssembly, and it runs on Windows 7 or later, and Mac, and all of these things. It has its own processors that basically it'll basically implement to use this. So V8 can run in a standalone, or it can be embedded to any C++ application. So you can go ahead to that link and you can download the Chrome V8 engine. It's open source. You can go take a look at the source code and dig through all of that and look at some of the C++. If you got time on a Saturday night, go through and download that and just go through the code. Go crazy. But basically the interesting thing is that you can actually create a JavaScript program and embed this, and basically you can extend the language, if that makes any sense. You could add some syntax in here to like say delete all data, and whatever your logic is, basically you can wrap it in a way that you could V8 would transpile it down or understand that this is adding to the extending the JavaScript language. So if you wanted to at the client side call that delete all data, whatever it is, the browser is not going to give you in your program is not going to throw errors, if that makes any sense. It'll actually allow you to add on to the languages. So basically, what's important, as I said, is this V8 engine translate JavaScript to machine code. So JavaScript in Node, if we're speaking specifically about Node.js and how it understands JavaScript, is it'll take that JavaScript that you wrote, that syntactic sugar, and V8 will translate it down to machine code. And machine code basically is instructions that the processor can understand. And V8 again is written in C++. So if we have on the left there the level of abstraction, at the UI level you're dealing with JavaScript code, or not at the UI level, but at the node level when you're working with your JavaScript, and you're doing a bunch of stuff with which we'll get into with modules and all streams and all these things. Then the V8 engine will basically take that, transpile it down to C and C++, and then again it'll get further down, it'll become assembly code, and then further down it'll become machine code that this processor can understand. So when we're talking about processors and we're talking about servers, like this is quite powerful, and historically it's been a server side kind of technology, like C Sharp, Java, these kind of things that would be kind of the server layer, right? Again, in behind the scenes, they're doing all this compiling and translating down, but never would we be working on JavaScript to do these type of things, right? So on the right, on the high level, basically, you have a high level language down to assembly, down to machine code, down to processor, right? And when we're talking about machine code, we're talking about ones and zeros and all these types of things, this binary stuff. That are the instructions for the processor, right? And when we start talking about Node.js, you'll actually see how powerful it is, right? I mean, much farther on, we may talk about that one of the powers of Node.js, and the reason why it is called Node.js is because it can be spawned on multiple nodes, right? Forever, how many processors you have or CPUs you have on a server, you can then spawn out different instances of Node, right? And that makes it very powerful. And there's a lot of powerful things, and the reason why Node is taken off in a big way. But that's a reference of how V8 fits into that equation, right? And V8 is only from Chrome. There's all these other JavaScript engines that play the same part in the browser, that deals with that compilation and transpilation of the JavaScript in code that the browser will understand. And again, remember the browser is installed on your machine, right? Your machine has a processor, and C++ is running and doing that locally on your machine, right? You may not know it. You just have a browser and you're surfing the web, but there's a lot of stuff going in behind the scenes, right? So Firefox has something called SpiderMonkey. What's that? I don't even remember. Opera over there on the top right has something called Nitro. But really, we're talking about Chrome and V8. IE has Shaka. Well, you know what? IE is not really hasn't been performing well lately. So whatever engine they're using is quite slow, to be honest. Uh, and really, when you think about Chrome and why it's so popular, is people think it's fast, right? Because the engine is fast, and they rewrote V8 completely. They rewrote it, and basically that's why you feel when you're writing Chrome it's lightning fast. So intro to Node.js. We talked a bit about it, and we're gonna get into a lot of the features of it, but we're just gonna give a little bit of a little overview of it and some history on it. So believe it or not, Node.js is 10 years old, so it's been around for a while, but it seems new still. It's still newer in that broad range of server technologies. In comparison, though, JavaScript is 24 years old, and the web is 30 years old. Wow. I still remember working on vanilla JavaScript, right? Not to say when it was 24 years old, but somewhere in that time. And I thought JavaScript was extremely brittle, because there wasn't a lot of tools to work with, and it was a very bad experience. Working with the DOM, there wasn't a lot of information back then. There wasn't a lot of material and forums like there is now, and it just felt really bad to work with. How naive I was, because of that pain that we talked about, that dynamicness, that 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 Wild West kind of feeling. Basically, you can extend anything in JavaScript, and it's typeless, right? Because of that, now we see all of these frameworks popping up, right? And all this stuff is possible. So my statement way back then, it was in a job interview, and that's the reason why I didn't get the job interview, because to be honest, I didn't really understand what I was talking about then. But 10 years isn't a very long time in technology, but it seems like Node's been around forever, and it was really innovative, and it still is because it's an event-driven approach. And the guy who created it was a guy named Ryan Dahl, and he has a very nice keynote speech in there where he's actually 10 years ago, he's talking about Node.js, and I would suggest you go look it up. And he's um, basically talking about how server-side technology should be event-driven, like the browser. I mean, what a concept, right? Uh, before the server technology was very synchronous and very blocking in a sense, and he just said, well, the UI in the browser has event-driven architecture, meaning like, when there's something clicks, a user clicks a button, the user does a pull down, there's all these events that trigger other things, and it's very reactive and very, uh, it's just very event-driven, right? Event-driven is a whole different paradigm, and he took that approach and he said, let's do it on the server, and let's use JavaScript as well. At the time, it seemed crazy, but you know what? In the early days, you could tell it was going to be very popular because it was such a far departure from all of this, and it was very innovative, right? And that was 10 years ago, and it's taken off, and it's very powerful. So a bit of history because I like history. 2009 now. Talking now, it's probably 11 years old, right? Because 2020 right now at the time of this video, Node.js was born, and in the first form of npm was created. Now we're going to talk about npm in the next module, but know that they're closely together. They closely go hand in hand. npm is the package manager, Node package manager, in fact, and we'll talk about that. The next year after that, Express was born. So Express is that API layer that's going to bridge the gap between the server and the web. We're going to get into that in other modules. Socket.io is born. So Socket.io, it's basically deals with these sockets, web sockets across the TCP IP protocols on the network layer. So again, the node has a lot of different things it can do. It can be a web server. It can be used for networking. It can be used for many things, right? So we'll get into that. 2011, npm hits 1.0, so npm became, kind of its first version, and then big companies started adopting Node.js, like LinkedIn, Uber. And Happy is born. By the way, Happy is an alternative to Express that has more features. Some people love it. Some people like Express. Just a different flavor. 2012. Now some of the things happened here. I just kind of like put the most important ones that I felt, but there's some other stuff that happened in between the scenes, but in between the years. But 2012 adoption continually very rapidly increased. 2015 the Node.js Foundation is born. IO.js, which was a major fork in ES6, was merged back into Node.js. Basically a feature that allows some ES6 features and all of this stuff. So basically encapsulated inside of Node.js. Node 4 was released. 2016, the left pad incident. So I'm going to talk about that one in the next module, but it's actually quite funny. It really deals with the npm and the repository there, the whole thing with where you can download these packages from, and I'll get into that. It's quite funny, but basically that guy broke the internet for a little while. The person who created that package, it actually had very big consequences, and I'll talk about that in the npm module. So 2016, Yarn is born. So Yarn is a direct competitor to npm, another package manager that Facebook created. So they say it's a bit performant, but it maybe at one time was, and then Node package manager kind of increased their performance, and you know what? There's two camps again, but competition is good. Node 6 is released 2016. 2017, so now we're getting closer to where we are. npm focuses more on security, which is a good thing. Node 8 was released, HTTP2. V8 introduces Node into the testing suite, officially making Node a target for the JavaScript engine, in addition to Chrome. So that year was significant because 3 billion npm downloads every week. Every week, that's 3 billion. That's a lot. Now, if you don't know, again, at the time of this video, just a couple days ago, Microsoft has finally stepped in and has purchased npm, and now it's coming into their family along with GitHub and all these different things. So now they basically have realized how important Node package manager is to the whole JavaScript ecosystem because everybody's using it. So they've basically gone and acquired that, and now they're in direct competition with Facebook at that level, which is the package manager and the builds and all these things. So that's relevant. 2018, again, another version of Node and some experimental support. So basically, that's kind of a history of where it was and where we're going. So we're going to give an overview of the core. Again, we're going to get into a lot of more technical code and concepts. This is kind of an overview, and then we'll get into again npm, and then we'll have some reference of what we're going to be doing, and then we're going to take baby steps and get into some of the coding, right? So the Node core basically is like this. It looks like this. So we have this Node.js API layer that, again, you basically can interact with that with all of the features of Node and some of the syntax. You might have a file system module, and you might need to use that file system module to open a directory and close a directory and delete a directory and these types of things. You might have a stream. We talk about data stream, and you have all those methods and things like that correspond to the API, right, that you're interacting with. Behind the scenes, Node is, again, when you say make directory, that's in JavaScript, but it's going to basically go through and get transpiled down, and it's going to basically do something with that JavaScript, and it's gonna go through all the different things. The bindings, so Node bindings, basically, V8 doesn't really understand the database of the connection. It kind of bridges the gap between V8 and say some of the other pieces, right? C++ add-ons. So again, Node JavaScript is a syntactic sugar. Underneath the covers, there's C++ and C at the server level. V8 we talked about, which is the JavaScript engine, and then we have libuv. So libuv is very important. libuv is very powerful. libuv takes care of a lot of the, and we'll get into a lot of the event-driven architecture and many other things. And we have a bunch of other modules there. HTTP and parser, like these things are built in. HTTP, basically, when you're talking about a web server handling HTTP requests. Open SSL, those are secure sockets, secure protocols. zlib, so zlib is another module. Basically, you're talking about compression, file compression, data compression, all built in, right? At the Node.js API layer, you may basically, as an example, you might require zlib, and now you have something that you can do compression on some big data or some files or data streams. Basically, you could write to a file, and then you could compress it right away into a type of zip file. Basically, that's built in. In a couple lines of JavaScript code, 3 lines, you could basically do all that, and it's pretty impressive, to be honest. Underneath the scenes, there's probably lots of code, lots of things going on that we're protected by. We don't see it. We just see our 3 lines of code, and we're just like, all good. So what libuv is, kind of interesting, right? You can't make this stuff up. libuv actually stands for Unicorn Velociraptor Library. I can't even say it, but basically, that's who said programmers don't have a sense of humor, right? So libuv basically developed to provide asynchronous I/O. So basically, all that stuff I'm talking about, like files, sockets, all this stuff, it's asynchronous. It's provided by this. It has a very famous concept called the event loop, and that's one of the whole pieces that makes Node.js very, very interesting, very asynchronous, very fast, and we'll get into all that. But so some things it does asynchronously is all the TCP and UDP sockets. It basically handles all that stuff, all those connections, all those protocols. Communication across those channels, the event loop, which is a very big thing in itself. That whole architecture, the asynchronous DNS resolution, file system read write, data streams, buffers, these kind of things. It handles all that, and it's written in C, right? So it's a C library. A C library that it gets very close to a lot of POSIX commands, like the old Unix commands. You'll be very familiar with that kind of stuff if you've done that stuff before, like piping things, catting things, all this kind of file-based stuff that you've done in that kind of language it's all encompassed in this library, and then again, it's built into that architecture of Node.js. Some other pieces there, other low-level components such as HTTP and parsers, zlib, like we talked about, compression, mostly written in C and C++. Application API that we're talking about, your code is here. This is where your code is, the modules. There's a bunch of Node.js modules built in, like buffer, like I talked about, some global stuff, written in JavaScript, compiled to JavaScript through, so okay, you can compile to JavaScript through TypeScript, CoffeeScript. So you could actually, so if we're talking about that TypeScript, you could use that. If you were talking about Angular and these kind of things, they have something called TypeScript. And basically what it allows is it allows type checking, strongly typed. Basically, it's basically a plugin that will basically give you transform your JavaScript into strongly typed script, if that makes any sense. It's kind of like you're programming in C# or Java. It'll enforce types on you. So if you hate the dynamic typing of JavaScript, this is a way of enforcing types, if that makes any sense at all. Bindings, basically wrappers that are bridges the gaps so different languages can communicate in the architecture. So installing Node.js, basically you can go to the official site, nodejs.org, and download an official package for any platform. Once you install it, it'll be available to you, available in Windows, say. Another convenient way is to install Node.js through a package manager. Every system has its own. Other package managers for Linux and Windows are listed here. Once you have it running, you can then run it from the command line. So the usual way is to run it in Node.js program is to run Node globally, a globally available command, once you install it, and pass the name of your file. So in your Node application, you might have an app.js, let's say, and then once you can, at the command line, once you call Node, a good check would be at the command line node -v, which will actually check the version of Node. And if you have it installed, it'll give you the version of it at the command line. And then you can execute JavaScript files right on the command line. So you could have an app.js that has very simply like a hello world. And then at the command line, as long as you make sure there's two things, that you're in the right directory, the same directory as the file, you can run it. And once you run it, to get out of that shell, that Node shell, if it's doing something and you're stuck, you have to remember that to exit the program, you have to use Control plus C command to kind of get out of the terminal window to get control back. Now, I'm going to go through that in the next module. I'll go through a little example of using Node and NPM and getting familiar with the command line interface.